You look up at the night sky, and it feels endless. Galaxies, stars, light stretching across billions of years. But everything you can see, everything telescopes have ever captured, is only a tiny part of something much larger, because there is a limit, a boundary we call the observable universe, not because the universe ends there, but because that's as far as light has had time to reach us. And beyond that boundary, there is no data, no images, no confirmation of what exists, only theories, only possibilities. But here's the question. If the universe doesn't end there, then what's on the other side? Welcome to falling into space. And if you're ready to explore what lies beyond everything we can see, don't forget to subscribe. Because tonight, you're about to step past the edge of the known universe. You are standing at a boundary you cannot see. Not a wall, not an edge in space, but a limit, defined by time itself. Everything you have ever observed, every star, every galaxy, every faint glow captured by telescopes, exists inside what scientists call the observable universe, a region roughly 93 billion light years across, not because that is the true size of everything, but because that is as far as light has had time to reach us since the beginning. And beyond that, there is silence. The observable universe is not a physical barrier. You could travel toward it forever, and you would never hit it, because it moves. As space expands, distant galaxies are carried away from us. The light they emit today will never reach Earth, not because it disappears, but because space itself stretches faster than that light can cross it. This means something unsettling. There are places in the universe that exist right now that we will never see. No matter how powerful our telescopes become, no matter how long we wait, their light will never arrive. So when you imagine the edge of the observable universe, you are not imagining the end of space. You are imagining the limit of information. And beyond that limit lies everything we don't know. But we can still ask the question, what exists beyond it? To understand that, you first need to understand how we got here. Go back 13.8 billion years to a moment when everything was compressed into a state so dense, so hot, that the laws of physics as we know them begin to break. The Big Bang. Not an explosion in space, but an expansion of space itself. At that moment, the universe began to grow, and it has never stopped. In the earliest fraction of a second, something extraordinary happened. Inflation, a period where the universe expanded faster than the speed of light. Not because objects were moving that fast, but because space itself was stretching. Imagine drawing two dots on a balloon and then inflating it rapidly. The dots move apart, not because they are traveling, but because the surface beneath them expands. That is what happened to the universe. And during that brief moment of inflation, regions that were once close together were pushed incredibly far apart. So far that some of them are now beyond our observable limit, which leads to something profound. The observable universe is only a small part of a much larger whole, a much larger universe that continues beyond what we can detect. But how much larger? We don't know. It could be slightly larger, or it could be infinite. An endless expanse of space filled with galaxies that stretch beyond any boundary you can imagine. And if that is true, then the universe does not have an edge. It has no final point, no place where everything stops. Only more space, more galaxies, more regions, just like the one you are in. And this is where the idea becomes difficult to understand, because your mind is used to limits, to edges, to boundaries. But the universe may not have any. Instead of ending, it simply continues. Forever. Now imagine this. Beyond the observable universe, there may be galaxies arranged in patterns similar to ours, clusters, filaments, vast cosmic structures. But there may also be regions that are completely different. Areas where matter is distributed differently, where galaxies formed in unusual ways. Because while the laws of physics appear consistent, the initial conditions of different regions may not be identical. And if the universe is large enough, then somewhere those differences become significant. Some regions may look almost identical to ours, and others completely alien. But you will never see them, because they are beyond the reach of light, beyond the reach of observation. And yet, they exist. This is what makes the question so powerful, because you are not asking about something imaginary. You are asking about something real, something that exists right now, just beyond your ability to detect it. And that changes everything, because it means that what you know about the universe is incomplete. Not slightly incomplete, but fundamentally limited. You are observing a small region and trying to understand the whole, like looking at a single grain of sand and trying to describe an entire desert. And yet, even with that limitation, you can still learn something important, because the observable universe is not random. It has structure. Galaxies form clusters. Clusters form superclusters. These structures connect in vast filaments, creating what scientists call the cosmic web. And this web extends outward, beyond what we can see, which suggests something important. The universe beyond the observable limit may follow the same large-scale structure. Not chaotic, not completely different, but consistent. A continuation of what we already observe. And if that is true, then beyond the observable universe, there is not nothing. There is more of the same. More galaxies, more stars, more worlds, and possibly more places where life could exist. But you will never confirm it, because the light will never reach you. And that is where the mystery begins, because you are standing at the edge of what can be known, looking into a region that is real but forever hidden. And the deeper you think about it, the more unsettling it becomes. Because the observable universe is not the boundary of space. It is the boundary of your knowledge. And beyond it, the universe continues without you. Now imagine this in a different way. Not as a boundary you are standing near, but as a horizon that moves with you. No matter where you go in the universe, you always carry your own observable universe with you. If you were somehow transported billions of light years away from Earth, you wouldn't suddenly see the true edge of everything. Instead, a new observable region would form around you, centered on your new position, filled with galaxies you have never seen before, while others disappear forever behind you. This means something very strange. There is no single observable universe. There are countless ones, each tied to a different point in space. Every galaxy, every star system, every possible observer has its own version of what can be seen and what is forever hidden. From Earth, you see one cosmic horizon. From a distant galaxy far beyond your reach, an entirely different sky exists, with its own visible limits and its own unreachable regions. And that leads to a powerful realization. When you ask what exists beyond the observable universe, you're not asking about a fixed place in space. You're asking about regions that are invisible to you, but not invisible in general. Somewhere in a distant galaxy far away, an observer might be able to see areas of the universe that are completely hidden from Earth. At the same time, parts of our observable universe may be forever beyond their reach. So the unseen universe is not empty. It is simply unseen from here. This idea becomes even more complex when you consider the expansion of space. Galaxies are not just moving away from us through space. Space itself is stretching. The farther a galaxy is, the faster it appears to move away. At extreme distances, this expansion becomes so strong that galaxies recede faster than the speed of light, not because they are breaking the laws of physics, but because the fabric of space between us is growing. Once a galaxy crosses that threshold, its light can no longer reach us. It fades, slowly at first, then completely. From our perspective, it disappears from the observable universe, but nothing has actually vanished. That galaxy still exists, still forming stars, still evolving. It has simply moved beyond our cosmic horizon. Over time, more and more galaxies will cross that boundary. The observable universe is not growing in the way you might expect. While light from distant regions continues to arrive, the accelerated expansion of the universe ensures that eventually, fewer new regions become visible. Instead, distant galaxies drift away faster and faster, becoming dimmer, redder, and eventually undetectable. Far into the future, the night sky will look completely different. If you were to stand on Earth billions or even trillions of years from now, you would not see thousands of galaxies spread across the sky. You would see almost nothing beyond your own galaxy. The Milky Way, merged with its neighboring galaxies, would remain as a single island of light in an otherwise dark universe. Everything else would have moved beyond the observable limit, leaving no trace behind. To a future observer, it might seem as if the universe is small, isolated, finite. They might not even realize that countless galaxies once existed beyond what they can see. This creates a strange kind of cosmic illusion. The size and structure of the universe depend on when and where you observe it. What you can see is not the full story, only a temporary window into a much larger reality. Now take this idea even further. If the universe is infinite, then beyond the observable horizon, there are not just more galaxies. There are more regions that look similar to ours. Given enough distance, patterns begin to repeat. Matter distributes itself in ways that are not completely random. The same physical laws apply everywhere, and with infinite space, the same configurations of matter could occur again. Somewhere far beyond what you can ever observe, there could be a region of space almost identical to this one. another galaxy like the Milky Way, another star like the Sun, another planet like Earth, and perhaps another version of you looking up at the sky and asking the same question. This is not science fiction in the usual sense. It is a possibility that arises from the idea of an infinite universe combined with the laws of probability. If space truly has no end, then anything that can happen within the laws of physics could happen again, given enough distance. But there is a limit to how much this idea can be tested. Because no matter how far you imagine traveling, no matter how advanced your technology becomes, you cannot cross the observable boundary fast enough to reach those regions. The expansion of space ensures that they remain out of reach. The faster you try to move toward them, the faster space stretches between you and them. It is not just difficult to reach the edge, it is impossible. This is what makes the concept of beyond the observable universe so unique. It is not just unknown, it is unknowable in a direct sense. You can build theories, you can create models, you can use mathematics to describe what might exist, but you cannot see it. You cannot measure it directly. You cannot confirm it with observation in the way you confirm things within your observable region. And yet, the evidence that something exists beyond is overwhelming. The uniformity of the cosmic microwave background, the large-scale structure of galaxies, the predictions of inflation theory, all point toward a universe that extends far beyond what we can observe. The observable universe is just a small patch, like a bubble, within a much larger space. And that leads to a final thought. You are not at the center of the universe, but from your perspective, it always feels like you are. No matter where you stand, the observable universe expands outward around you in every direction. It creates the illusion of centrality, even though there is no true center. Every observer, everywhere, experiences the same thing, which means that beyond your horizon, there are countless other horizons, each with their own unseen regions, each with their own hidden realities. And when you look into the night sky, you are not just seeing distant stars and galaxies, you are seeing the limit of what is possible to know from where you stand. Everything beyond that limit still exists. It is still out there, stretching across distances so vast that they break intuition, filled with structures and patterns you may never understand. And no matter how far your imagination goes, the universe continues further, always just beyond reach. Now imagine pushing the idea even further, not just beyond what you can see, but beyond what you can even describe with certainty. When you think about the universe outside your observable horizon, your mind tries to extend what you already know. More galaxies, more stars, more of the same cosmic web stretching outward forever. But there is a deeper possibility, one that challenges not just your knowledge, but the nature of reality itself. Because the universe beyond the observable limit may not only be larger, it may be fundamentally different in ways you cannot directly detect. Everything you understand about physics comes from a single region of space. Every law, every constant, every rule that governs matter and energy has been measured within the observable universe. And so far, everything appears consistent. Gravity behaves the same. Light moves at the same speed. The same elements form in stars. The same patterns appear in galaxies. But what if that consistency is only local? What if the laws of physics are not identical everywhere? This is where the idea becomes uncomfortable, because beyond the observable universe, there could be regions where the constants of nature are slightly different, where gravity is stronger or weaker, where particles behave in ways that would seem impossible here. These differences might be subtle, or they might be so extreme that matter as you know it could not even exist. You would never see those regions. Their light would never reach you, but they could still be part of the same larger universe. This idea is connected to one of the most debated concepts in modern cosmology, the possibility of a multiverse. Not multiple universes separated by distance, but multiple regions within a greater structure, each with its own properties. Inflation, the rapid expansion that occurred at the beginning of everything, may not have happened just once. It could be an ongoing process, creating vast bubbles of space, each expanding on its own, each potentially forming its own version of a universe. You are inside one of those regions. Everything you observe, everything you measure, everything you understand belongs to this bubble. But there could be others, endless in number, forever out of reach. This is not a simple extension of space. It is a shift in perspective. Instead of imagining a single universe that stretches infinitely, you begin to imagine a structure where different regions may not even share the same rules. And if that is true, then asking what lies beyond the observable universe is not just asking about distance. It is asking about possibility. Now bring the focus back to what you can actually measure. Even within the observable universe, there are clues about its larger structure. The cosmic microwave background, the faint afterglow of the Big Bang, is remarkably uniform in every direction. This suggests that the universe was once in a very similar state everywhere, before it expanded and cooled. But there are tiny fluctuations in that background. Slight differences in temperature, small irregularities that grew over time into galaxies and clusters. These patterns give you a map of the early universe, a snapshot of how everything began to form. And those patterns do not suddenly stop at the observable edge. They continue. The same processes that shaped the visible universe likely shaped the invisible parts as well, which means the structure you see, the cosmic web of galaxies, may extend far beyond your horizon. Filaments connecting clusters, vast empty voids between them, patterns repeating on scales so large that they become difficult to imagine. But there is a limit to how much structure can exist. On the largest scales, the universe appears homogeneous. This means that if you zoom out far enough, everything starts to look the same. No preferred direction, no special location, just a uniform distribution of matter and energy. This principle, known as the cosmological principle, suggests that the universe is not centered anywhere, which leads to another strange conclusion. If there is no center, then there is no edge in the traditional sense. The observable universe is not a bubble at the edge of everything. It is a bubble within everything, surrounded not by emptiness, but by more of the same. Now imagine trying to reach that beyond. Even if you could travel at the speed of light, you would never catch up to the expansion of space. The regions beyond your observable horizon are moving away from you too quickly. The distance between you and them grows faster than you can close it, so the boundary remains, not because something blocks your path, but because the universe itself prevents you from crossing it. This is what makes the observable universe such a powerful concept. It is not defined by walls or edges, but by time and motion. It is a limit created by the finite speed of light and the expansion of space. And that limit changes how you understand everything, because it means that there is always more space beyond what you can see, more galaxies beyond what you can detect, more reality beyond what you can confirm. And yet, no matter how much more there is, your experience of the universe will always be confined to what is observable from where you are. This creates a paradox. You know that the universe is larger than what you can see, but you can never fully prove how much larger it is. You can build models, you can test predictions, you can gather indirect evidence, but the full picture remains incomplete. And perhaps it always will, because the universe is not just vast, it is structured in a way that limits your ability to explore it completely. It gives you enough information to understand its basic rules, but not enough to see everything. And so, when you ask what exists beyond the observable universe, you are not just asking about distance. You are asking about the limits of knowledge itself, a boundary that does not stop reality, but stops you from seeing it. And beyond that boundary, whatever exists continues, unaffected by your inability to observe it, stretching across a reality that is far larger, far deeper, and far more complex than anything you can ever fully understand. Now imagine that you could somehow step outside the limits of observation, not physically, because nothing can actually leave the observable universe and look back at it from the outside, but conceptually. Imagine you could see the entire structure at once, like looking at a map instead of standing inside the landscape. From that perspective, the observable universe would not look like a center. It would look like a sphere around you, defined only by how far light has traveled. And somewhere else, far beyond your reach, another observer would see a completely different sphere, centered on them. There is no special position, no privileged location. Every point becomes the center of its own observable universe. And that leads to a deeper realization. The universe does not expand into something else. It expands everywhere at once. This is one of the most misunderstood ideas. When you hear that the universe is expanding, it is natural to imagine it growing into empty space, like a balloon expanding into the air around it. But that picture is incomplete. The universe is not expanding into anything. Space itself is expanding. There is no outside, no surrounding void waiting to be filled. The expansion is happening within the fabric of reality itself, which means that asking what is beyond the universe may not even be a meaningful question in the way you expect, because there may be no beyond in the traditional sense. But there is still something beyond the observable part, and that difference is important. Now consider how the expansion affects what you see. Light travels at a finite speed. This means that when you look at distant galaxies, you're not seeing them as they are now, but as they were billions of years ago. The farther away something is, the further back in time you are looking. So the observable universe is not just a region of space. It is also a window into the past. At the very edge of what you can see, you are looking at light that has been traveling since the early universe, shortly after the Big Bang. This faint glow, known as the cosmic microwave background, marks the point where the universe first became transparent to light. Before that moment, everything was too hot, too dense for light to travel freely. So there is another kind of limit, not just a distance limit, but a time limit. You cannot see beyond a certain point in time because light from before that era cannot reach you in a form you can detect. And beyond that, there is still more history. Moments that existed, events that happened, conditions that shaped everything you now observe. But they are hidden behind a barrier of physics. This adds another layer to the question. When you ask what exists beyond the observable universe, you are also asking what exists before the earliest light you can see. And the answer becomes even more uncertain, because the physics of that era is not fully understood. Now shift your focus again. Instead of thinking about what lies beyond, think about what lies ahead. As time continues, the observable universe changes. Galaxies that are currently visible will move farther away. Their light will stretch, becoming redder and weaker. Eventually, they will fade beyond detection. At the same time, light from regions that were once closer may still be arriving, adding new information to your observable horizon. But this process does not continue forever, because the expansion of the universe is accelerating, driven by something we call dark energy, a mysterious force that pushes space apart faster and faster. And this acceleration creates a future horizon, a limit beyond which events can never influence you, no matter how long you wait. This means that over time, your observable universe does not simply grow, it changes. It loses access to distant regions. The universe you can observe in the far future will be smaller in terms of accessible information, even if space itself continues to expand. This is one of the most surprising aspects of cosmology. The universe is getting larger, but your view of it is becoming more limited. Now consider what this means for knowledge. Everything you know about the universe comes from the light that reaches you. If that light disappears, so does your ability to study those regions. Future observers may never know that distant galaxies once existed. They may see a quiet, empty sky dominated only by their local group of galaxies. From their perspective, the universe will seem small and simple. They may build theories that describe only what they can observe, unaware that a vast, complex structure lies beyond their horizon. This creates a strange situation. Knowledge of the universe is not just limited by technology. It is limited by time. You are living in a period where the universe is still visible on large scales, where distant galaxies can still be detected, where the cosmic microwave background can still be observed. But this window will not last forever. It is temporary, which means that right now you are in a unique position. You can see farther than future civilizations may ever be able to. You can study a universe that will eventually become hidden. And yet, even with this advantage, you still cannot see everything. There will always be regions beyond your reach, always more beyond the horizon. And that leads back to the original question. What exists beyond the observable universe? The most honest answer is this: more universe, more space, more galaxies, more structure, more history. but also more uncertainty. Because no matter how far you extend your models, no matter how precise your measurements become, there will always be a limit, a boundary not of reality, but of observation. And beyond that boundary, the universe continues in ways you may never fully understand. Not because it is impossible to imagine, but because it is impossible to see. And that difference is what keeps the mystery alive. Now imagine something even more difficult to accept. What if the universe you observe is not just a small part of a larger whole, but a small part of something that has no repeating scale, no final pattern, no complete map that could ever be drawn? Because when you try to describe what lies beyond the observable universe, you are not just extending space outward. You are extending uncertainty, and that uncertainty grows the farther you go. Everything you understand about the universe is based on observation and inference. You see patterns in galaxies, you measure radiation, you calculate expansion, and from that, you build a model of reality. That model works incredibly well, but only within the region you can test. Beyond that region, your confidence begins to weaken, not because the laws suddenly stop working, but because you can no longer confirm them directly. And this is where cosmology becomes something unique. It is a science that reaches its limits. You can describe the universe with equations. You can predict how it evolves. You can simulate what lies beyond. But at some point, you reach a boundary where experiment becomes impossible. No signal can come from there. No observation can verify it. And yet, the universe does not stop. So you are left with something strange, a reality that exists but cannot be fully tested. Now consider this. Even within the observable universe, there are limits to what you can measure. You cannot know the exact total size of the universe. You cannot determine whether it curves back on itself at some unimaginable scale, or whether it extends infinitely in all directions. The geometry of the universe is still being studied. Measurements suggest that on large scales, space appears flat. But flat does not necessarily mean infinite. It means that within the region you can observe, there is no detectable curvature. But beyond that region, the curvature could change, or it could remain the same forever. There is no way to know for certain. This leads to two possibilities. The universe is finite, but so large that its edges are beyond anything you could ever observe. Or the universe is infinite. And if it is infinite, then something extraordinary follows. Everything that can happen does happen. Not in time, but in space. Given infinite space and a finite number of ways matter can arrange itself, patterns must repeat. Somewhere, far beyond your horizon, there could be regions identical to this one. Not just similar. Identical. The same distribution of galaxies, the same stars, the same planets. And if you extend that idea further, the same Earth, the same events, the same moment you are experiencing right now, happening again and again, endlessly. This idea is difficult to accept, but it is a natural consequence of infinity combined with physical laws. And yet, it remains untestable, because those regions are beyond your observable limit. You cannot confirm their existence. You can only explore the logic that suggests they might exist. Now shift your thinking again. Instead of focusing on space, think about time. The universe has existed for 13.8 billion years. But that is only the time since the Big Bang. What happened before that? This question is even more uncertain. Some theories suggest that time itself began at the Big Bang, that there is no before in the way you understand it. Others suggest that the Big Bang was not the beginning, but a transition, a phase in a larger cycle, a moment in a universe that has existed forever. Or perhaps one of many universes, each with its own beginning. Again, there is no direct way to test these ideas. They exist at the edge of physics, at the boundary between science and speculation. But they are still grounded in logic. They are attempts to describe what lies beyond what you can see. And that is the key idea. When you ask what exists beyond the observable universe, you are not asking a simple question. You are asking about the limits of reality as you can understand it. A limit defined not by what exists, but by what you can know. And this is where the perspective changes. Because instead of thinking of the observable universe as a small piece of a larger structure, you begin to see it as your entire accessible reality. Everything beyond it may exist, but it does not interact with you. It does not influence your observations. It does not change your measurements. From a practical point of view, it might as well not be there. And yet, it is. That contradiction is what makes this subject so powerful. You are surrounded by a universe that is far larger than you can observe. A reality that extends beyond your reach in every direction. And no matter how much you learn, no matter how far your understanding grows, there will always be more beyond the horizon. Always something just out of reach. Not because you are limited, but because the universe is designed that way. Endless, expanding, unknowable in its entirety. And that is what lies beyond the observable universe. Not emptiness, but more existence, stretching infinitely into the unknown. Now imagine something even more unsettling. Not just that the universe continues beyond what you can see, but that your very idea of seeing reality may be fundamentally incomplete, because everything you know about the universe comes through one medium, light. Every galaxy you observe, every structure you map, every distant signal you detect is carried by photons traveling across space. But what if light is only telling you part of the story? There are things in the universe that do not interact with light in the way matter does. Dark matter. You cannot see it. You cannot touch it. You cannot detect it directly with your eyes or telescopes. And yet, it exists. You know this because of its gravitational effects. Galaxies rotate in ways that cannot be explained by visible matter alone. Clusters of galaxies bend light through gravitational lensing, revealing hidden mass that cannot be seen. This invisible matter makes up most of the mass in the universe, which means that everything you see, stars, planets, gas, dust, is only a small fraction of what is actually there. Now extend that idea beyond the observable universe. If even within your visible region, most matter is invisible, then beyond that region, the unknown becomes even larger, because you are not just missing distant galaxies. You are missing entire structures made of matter you cannot directly observe. And that leads to something profound. The universe beyond your horizon is not just unseen. It is mostly invisible, even if you could see it. Now consider something else. Dark energy. A force you do not understand, but can measure. It drives the accelerated expansion of the universe. It pushes galaxies apart. It shapes the large-scale evolution of space. And it dominates the energy content of the universe, more than all matter combined. Which means that most of the universe is made of something you do not understand. Not just beyond the observable limit, but here, right now. So when you ask what exists beyond the observable universe, you are asking about a region where you cannot see most matter, you do not understand most energy, and you cannot receive information from it. And yet, it exists under the same unknown forces. Now, imagine removing light completely. Imagine a universe where nothing emits light. You would not see galaxies. You would not see stars. You would not see structure. And yet, gravity would still be there. Matter would still exist. The universe would still have form. This is closer to reality than you think, because most of the universe does not shine. Most of it is dark. Now take that darkness and extend it beyond the observable universe. You begin to realize that what lies beyond is not just hidden by distance, but hidden by nature itself. Even if the light could reach you, it would not show everything. This changes the meaning of your question. You are not just asking what exists beyond what you can see. You are asking what exists beyond what you are capable of detecting at all. And the answer becomes even more uncertain, because there may be structures, forms of matter, or even forms of energy that behave in ways completely different from anything you have observed. Not because they are impossible, but because they have not interacted with your region of space. Now imagine something even more extreme. What if beyond the observable universe, there are regions where the balance between dark matter and normal matter is different? Regions where galaxies form differently, where structures evolve in unusual ways, or regions where dark energy behaves differently, altering the rate of expansion, changing the fate of space itself. These ideas are speculative, but they are grounded in one fact. You only know what you can observe. Everything else is inference, and inference has limits. Now bring your focus back. Look at the night sky again. Every star you see, every faint galaxy, is a signal. A piece of information that traveled across space for millions or billions of years to reach you. And beyond those signals, there is silence. Not because nothing is there, but because nothing from there can reach you. This silence is not empty. It is full of unknowns. Unknown matter, unknown energy, unknown structures. A universe that exists but does not communicate with you. And that is what makes the concept so powerful. Because you are surrounded by a reality that is far larger than your perception. A reality where most of what exists is invisible, and most of what is visible is only a small part of the whole. And beyond your observable limit, that imbalance becomes even greater. More darkness, more uncertainty, more existence without evidence. And yet, you continue to explore it. Not with observation, but with thought, with models, with theories, trying to understand something that you may never fully see. And that is the true nature of what lies beyond the observable universe. Not just distance, but a deeper level of unknown, where even the idea of seeing is no longer enough. Now imagine something even more subtle, not something far away in distance, but something hidden in the way reality itself is structured. Because when you think about what exists beyond the observable universe, you naturally imagine more space, more galaxies, more of the same cosmic web stretching outward. But there is another possibility, one that does not rely on distance at all. What if reality has layers? Everything you experience is based on 3 dimensions of space and 1 dimension of time. That is the framework in which all motion, all matter, and all events take place. It feels complete. It feels absolute. But physics does not guarantee that this is the full picture. Some theories suggest that there could be additional dimensions hidden from direct observation, not far away, not beyond the horizon, but embedded within the structure of space itself. These extra dimensions would not be visible because they could be compact, curled up at scales far smaller than anything you can measure directly. Or they could exist in ways that do not interact with ordinary matter in a way you can easily detect. If that is true, then the universe you observe is only a projection of a deeper structure. And beyond the observable universe, that deeper structure may continue in ways that are not limited to the 3 dimensions you experience. Now take a step back. Even without extra dimensions, space itself may not be as simple as it appears. On large scales, the universe looks smooth and uniform, but at smaller scales, it becomes complex. Matter forms structures, clusters, and patterns. Gravity shapes everything, pulling matter into dense regions and leaving vast empty voids in between. But what happens at the smallest possible scales? At the level where quantum physics dominates, space may not be smooth at all. It may be granular, fluctuating, filled with tiny variations that constantly change. This is sometimes described as quantum foam, a concept where space at the smallest scales is dynamic and unstable, far from the calm, continuous surface you imagine. If that is true, then the universe is not just expanding outward. It is constantly shifting at every scale. And beyond the observable universe, this same structure would continue. Not as a calm, empty extension, but as a dynamic system filled with fluctuations, energy, and change. Now consider something even more interesting. The observable universe is defined by what light can show you. But there are other ways information can exist. Gravitational waves, for example, carry information through distortions in space-time itself. They move differently from light, interact differently, and can reveal events that light cannot. In the future, new methods of observation may allow you to detect signals from regions that are currently hidden. Not by seeing them directly, but by sensing their influence. Even so, there will always be limits, because the expansion of space still sets a boundary. No signal, no matter how it travels, can cross a horizon where space expands too quickly. So even with new ways of detecting the universe, there will always be regions beyond reach. And yet, the idea of layers adds something new to the question. Beyond the observable universe is not just more of the same. It may also include aspects of reality that you are not equipped to perceive directly, not because they are far away, but because they exist in a form that your current understanding cannot fully describe. Now return to something simpler. Imagine the universe as a pattern that repeats, evolves, and expands. Within your observable region, you see part of that pattern. You see how matter clusters, how galaxies form, how structures connect. Beyond that region, the pattern likely continues, but it may not be perfectly uniform. Small differences in the early universe could have been stretched across vast distances during inflation. Those differences may have created regions with slightly different distributions of matter, different densities, different arrangements. And over billions of years, those differences would grow, shaping entirely new cosmic environments. Some regions might be more crowded with galaxies, others more empty. Some might form large structures earlier, others might evolve more slowly. All part of the same universe, but each with its own local characteristics, and you will never see them, because they are beyond the reach of your signals, beyond the reach of your instruments, beyond the reach of your time. Now consider the most important idea of all. Everything you know about the universe is based on observation, theory, and interpretation. You build a model of reality from the information available to you. That model is powerful, accurate, useful, but it is not complete because it cannot include what you cannot observe. And that means the true structure of the universe is always larger than your model, always deeper, always more complex. No matter how much you learn, there will always be more beyond the observable limit. More structure, more variation, more possibility, and perhaps more aspects of reality that you have not even begun to imagine. So when you ask what exists beyond the observable universe, the answer is not just more space. It is more reality, a continuation not only in distance, but in complexity, in dimensions, in structure, in unknown properties. A universe that extends beyond your ability to fully describe it. And yet, it is still there, always present, always expanding, just beyond the horizon, where knowledge ends and possibility begins. Now imagine something even quieter than distance, even deeper than hidden dimensions or unseen matter. Imagine limits that are not set by space, but by understanding itself. Because when you ask what exists beyond the observable universe, you are not just pushing outward into darkness. You are also pushing inward, toward the edge of what your mind and your physics can describe. Everything you know about reality is built from models. You take observations, patterns, measurements, and you translate them into equations. Those equations become your way of predicting how the universe behaves. They allow you to explain gravity, motion, energy, structure. And within the observable universe, those models work. They are consistent, reliable, powerful. But beyond that region, something changes. Not reality itself, but your ability to describe it. Because every model has limits. General relativity describes how space and time behave on large scales. Quantum mechanics describes how matter and energy behave on the smallest scales. Both are incredibly accurate in their own domains, but they do not fully agree with each other. At extreme conditions, like the very beginning of the universe, or inside black holes, these theories begin to break down. And beyond the observable universe, those extreme conditions may exist in ways you cannot test, which means that the deeper you try to describe what lies beyond, the more uncertain your language becomes. You can extend your equations. You can propose new theories. You can imagine structures that go beyond current understanding. But you cannot confirm them. This is where physics meets its boundary. Not because reality ends, but because your tools for describing it reach their limit. Now, consider something else. Information. Everything you know about the universe is information carried to you. Light, particles, signals. And information has rules. It cannot travel faster than the expansion of space beyond a certain scale. It cannot be recovered once it crosses certain boundaries. This means that beyond the observable universe, information exists that will never reach you. Not now, not in the future. It is not hidden temporarily. It is hidden permanently. And this introduces a profound idea. There are truths about the universe that you will never be able to know. Not because you are not advanced enough, not because your technology is limited, but because the structure of the universe itself prevents that knowledge from ever arriving. Now imagine what that means. There are galaxies you will never see, events you will never observe, processes you will never measure, entire histories unfolding beyond your reach. And yet, they are just as real as the ones you can observe. This changes the way you think about knowledge. You are used to the idea that with enough time, enough effort, enough advancement, you can understand everything. But the universe does not guarantee that. It gives you access to part of the story and leaves the rest beyond your horizon. Now shift perspective again. Imagine an observer in a distant galaxy, far beyond your observable universe. They look at their sky. They see their own galaxies, their own cosmic background. And they ask the same question. What exists beyond what I can see? From their perspective, you are beyond that boundary. Your galaxy, your planet, your entire observable universe, invisible to them forever. And yet, both of you exist within the same larger reality. Two observers, each with their own horizon, each unable to see the other, each describing a universe that feels complete, but is not. This creates a kind of fragmentation, not of reality itself, but of perception. The universe is one structure, but it is experienced as many. Each observer sees a different slice. Each builds a model based on what they can detect. And none of those models can capture the whole. Now bring everything together. Distance limits what you can see. Expansion limits what can reach you. Physics limits what you can describe. Information limits what you can know. And all of these limits combine to define the observable universe, not as a physical boundary, but as a boundary of access. And beyond that boundary, the universe continues, unaffected by your observation, unaffected by your understanding. It evolves, it changes, it expands, just like the part you can see. And perhaps in ways that are completely different. Because without observation, without measurement, there is no way to constrain it. No way to fully define it. Only possibilities. And that is what lies beyond the observable universe. Not emptiness, not a simple continuation, but a region where reality exists without confirmation, where structure may continue, or transform, or diverge in ways you cannot predict. A place where the universe is still real, but no longer accessible. And that may be the most important idea of all, because it means that no matter how far you explore, no matter how much you learn, there will always be something beyond your reach. Not because it is hidden, but because it is fundamentally unreachable. Now you've reached the edge, not of the universe, but of everything you can ever know about it. Because the question was never just about distance. It was never just about what lies farther away than the farthest galaxy you can see. It was about limits. The limit of light. The limit of time. The limit of physics. And the limit of understanding. Everything you've explored, everything you've imagined, exists inside a region defined by those limits, a region we call the observable universe. But now you understand something deeper. That region is not the whole. It never was. Beyond it, space continues, not empty, not silent, but filled with galaxies, matter, energy, and structure, just as real as anything you've ever seen. Beyond it, reality continues. But something changes. Not the universe itself, but your connection to it. Because beyond that horizon, nothing can reach you. No light, no signal, no information. Those regions exist, but they do not communicate. And that changes everything. Because it means that reality is larger than experience, larger than observation, larger than anything you can confirm. Now imagine the full picture. A universe that expands endlessly, a structure with no center, no edge, no final boundary, only horizons. Each observer, in every galaxy, surrounded by their own observable universe, each one seeing a different slice of the same greater reality, and none of them ever seeing the whole. This is not a limitation of technology. It is a feature of the universe itself, a design where knowledge is always partial, always incomplete, and yet still meaningful. Because within that limited region, you have discovered galaxies, stars, planets, laws of physics, the history of cosmic evolution. You have mapped a universe that stretches billions of light years, and still, you stand at a boundary, a horizon that cannot be crossed. Not because something stops you, but because the universe is built in a way that keeps part of itself forever beyond reach. And maybe that is what makes it so powerful, because there will always be more. More space, more structure, more reality. Something just beyond what you can see. Something just beyond what you can prove. Something that exists without ever revealing itself completely. And in that sense, The observable universe is not a cage. It is a window into a much larger existence, a glimpse of something that continues infinitely in every direction. And no matter how far you look, no matter how deep you think, there will always be a horizon, always a boundary where knowledge ends and mystery begins. And beyond that boundary, the universe continues, silent, endless, and forever out of reach.